start because by the time it will start playing, it will already be 5.
Nice. Okay. Hey guys, everyone who's listening now and will be listening in the future, I guess. I'm Peter, and I guess you can't see this.
Hi, I'm Raghav.
And we're going to be the 2 TAs that are going to be going through the assignment 1 YouTube Live. So what YouTube Live is, we're typically going to go through the assignment, the requirements of it, some details about submission and grading, and then entertain some Q&A afterwards. In this particular assignment, we have a lot of code to go through in terms of the framework of isolation, so this one might be a little bit longer than future YouTube Lives, but we're going to get through it. So, starting off, the outline of this stream is going to be administrative details, which is going to be some things about the class in general, assignment details, things about when it's due, how it's going to be graded, etc. Assignment setup, so if you haven't installed the dependencies or something yet, I guess we'll link to it. Project structure, we're going to go through the isolation API and the notebook a little bit. Testing and grading, we're going to go over the grading setup on Gradescope and what you can expect out of that, and then finally we're going to be having a Q&A for everyone. So first of all, in the class in general, if you haven't completed assignment 0 or the plagiarism quiz, you should do so ASAP. Those are part of your final grade, and if you just forget to do them, you're really going to be regretting it later in the semester when you really need that like 2% of your final grade. So that's due January 19th, which is 4 days from now, which is, I guess, Sunday at midnight AOE. I'm not sure. January 19th, midnight AOE. Be sure to do that. Don't forget. Also, we have an introduction thread for all the students on Piazza. Go ahead and throw yourself in there if you haven't yet, or, look around at some of your fellow classmates. And there's also teaching staff introduction thread, so you can get to know us a little bit better and see some of our interests in terms of maybe artificial intelligence and outside of the technical sphere. So some details about this assignment. It was released this past Sunday, and it's due, it's a 2-week duration, so it's going to be due not next Sunday, but the Sunday after that. The biggest things that we have to say are start early. This assignment might take you quite a long time, and in particular, compared to other assignments, it might take time to play games on your local machine and test things. So it's not something that you can figure out in the span of 6 hours, so don't wait until right before the deadline. Also, if you haven't pulled from the repository since it was released, please do so. There are some changes that we'll talk about in a second, but just make sure you have the most up-to-date form of the assignment. And in terms of the material that's covered in this assignment, it's only going to be Lecture 1 game plan, so you don't have to worry about going on to search where they talk about A-star or UCS or anything. You can restrain yourself to Lecture 1 on Udacity, and that'll be fine. So the overall goal of this assignment is you're going to be implementing adversarial search algorithms to create a powerful agent, and you're going to try and beat a bunch of preset bots that we have. And these bots are going to be using more and more complex techniques as you go further down the assignment, so they're going to be harder to beat in general. And then what those bots actually are and the exact grading breakdown of the assignment. You can see it on Gradescope, I think, but in case you haven't. First 5 points, it's a simple give me. You have to implement OpenMove eval, which is discussed in the lectures. We're going to talk about some of the functions that maybe will help you in implementing that, but just writing that function correctly will give you 5 points. The next is defeating a random player, which is an agent that just takes completely random moves all the time. You have to beat it with an accuracy or a win rate of about 90%. That'll get you the next 30 points. Note that there isn't an in-between for testing the correctness of any of your algorithms. We only evaluate the correctness of your algorithms by putting you up against these bots. So that's something to note, I guess. Next, you have to beat a minimax agent that searches to a depth 2. Then you have to beat an alpha beta agent that searches to depth 4. And then you have to beat an iterative deepening and alpha beta agent
for the evaluation function, the secret evaluation function.
Yes. So the very last 5 points is a secret evaluation function that uses certain techniques that we have figured out and used in the past. And these last 25 points are pretty difficult to get. So that's probably going to take a lot of your time, because you have to get, there's a lot of different ways to approach it, and you might have to get pretty clever with it. So in regards to setting up the assignment with Jupyter and all the requirements, you can basically just look at assignment 0 for that. I think we have the same requirements.txt, and of course we just use Jupyter. So if you have project or assignment 0 set up and ready to go, you should be all good for assignment 1. This is the repository for assignment 1. You can run this command in your local terminal to clone it locally. In terms of the project structure, first we're going to go through isolation real quick, then we're going to go to the notebook, and hopefully that'll give you a good idea of what to look for in general. So I'm opening up isolation.py. All of you have this in your assignment repository, and it contains the basic framework of isolation. Now, a lot of it you don't have to know, you don't have to touch. It should be all handled for you. And you can ignore a lot of it unless you really want to get down into the weeds. In general, I'm just going to go through this. So anything, this is Python general, practice, but anything that begins with a double underscore, in general, you shouldn't have to look at. You should only be looking at functions that don't have that, I guess, that just begin with the lowercase character. So, for example, init, you probably don't have to look at this again unless you particularly want to. Get state and set state. So, in case you want to actually get the board state at any time, I don't think you have to use get state for a lot of things, but set state is really useful for testing. So you can see this is what we use in the local minimax tests. In case you want to set up a certain board with certain blocks and test how your agent will act in that certain context, you can use set state to immediately bring the board to a certain state, and you don't have to play a game and hope that you manually make all the moves to get to that board state. This is pretty useful, especially early on when you're just getting the hang of minimax, and if you want to test out how a particular rule that is clever might change an agent's behavior. So set state, apply move, again, double underscore, so general, you shouldn't need to touch it. Create laser, also you shouldn't need to touch it. I assume that everyone at this point has read through the notebook and knows what a laser and a trail and trailblazer isolation is. I guess we'll cover that in the notebook after this, which might have been, could have been better ordered, but it's fine. You can just skip ahead and skip back if you have this recorded. So create laser, you shouldn't really need. Copy, you shouldn't really need also. What we use this for is when, in the grading server, when we have a game being played, and in forecast, I guess, when you're forecasting a move, you take a board, you apply a move to it, and you get a new board. But we don't want that to happen to the actual board that's being played all the time. These are the hypothetical boards that you're using to look forward in time. So that's what copy is generally used for. All these are copies of the board and not the board itself. Forecast move, this is a big function that you're definitely going to have to use. As I just said, what it does is it creates, so if you want to see the impact that a certain move would take, you just need to have the current board state, and then forecast the move that you want to see the result of. That will give you 3 return values. One is the result of that move in terms of what the board state is going to look like, a flag to if that move resulted in the end of the game, and a string that contains Q1 or Q2 for who won. Normally, the way this works is if I make a move and the game is over, I win, because that means that my opponent could not make a move, and therefore the game is over. So be sure to just take that into account. I saw some people talking about the apply move, and that this also returns a certain flag for if the game is over or not. You shouldn't really be worrying about this. Apply move is a function that you shouldn't need to touch. You should be using forecast move. Bam. Get active player and get an inactive player, and similarly get active queen, get inactive queen. These are typically used for display purposes in the terminal, so you shouldn't really have to use them. Typically shouldn't have to use them. Inactive position and active position. This returns the current positions of the queens. You can use this. You shouldn't necessarily have to use this in traditional Minimax or Alpha Beta, but say you want a particular strategy that depends on where the opponent or where you are at a certain amount of time, or a certain board state, this is what you could use. Also similarly, get player position and get opponent position. The issue with get active and get inactive is that it depends on it's your turn or not. So say I want to get Q1's position. That can depend, if I'm using these two functions, I have to keep track if Q1 is active or inactive, and that can be a little bit tricky sometimes. So instead what you could do is get player position, which you can pass in the player that you want to get the position of, and it will handle this whole active player thing for you. Similarly, for get opponent position, this is a little bit of nuance. So get opponent position will return the position of the opponent of my player. So whatever player is not my player, because in some cases you don't have access to the opponent's player object, etc. So you should use this function to get your opponents. Hopefully that makes sense. Get inactive moves and get active moves. This is another function that's pretty important, along with get player moves and get opponent moves. Where do these go? So when you're doing Minimax and you're expanding out the game tree, you have to, in order to look ahead, you have to get all the moves for a current board state and then see the result of all those moves. And to get all those moves in the first place, you should be using get inactive moves, get active moves, or get player moves, get opponent moves. Again, this nuance between the two sets is sort of what I described already. So this, you have to, with these two, you have to take into account whether or not it's your turn, and get player moves, get opponent moves. Returns the moves a little bit more consistently. Yeah. Hopefully you guys know what I mean. Get moves underscore, you shouldn't need it. Get moves is used in all these things, but you shouldn't need to touch it. Get first moves, this again is sort of a function that I doubt that you guys will really want to use. It's just an easier way to return every board space, or every space on the board. It's used in the very start of the game and nowhere else. Generally, these functions you should only really need if you want to implement a particular specialized strategy. They're used internally for checking the validity of moves, such as, is the move in the board, is the move, is a certain space, doesn't have an X in it, doesn't have a queen in it. So again, you shouldn't really have to touch these unless you have something particular in mind. And then the doc strings hopefully take care of that. And then print board, this is what's used in the terminal when you run, I think, a human player object. If you want to just see an alternative of the visualization that's in the notebook. And then play isolation, this is the function that it will actually play a game given two player objects. And there's a time limit. An opponent or a certain player only has, I think this is milliseconds, so they only have a certain amount of time to make a move, and then if they don't make a move in that time limit, they will automatically lose the game, and it will be a timeout. Apply move right, again, you shouldn't need to touch it. Clear laser, you shouldn't need to touch it. game is text. So this is something in case you want to walk through the result of a game that you previously played. You can see that in play isolation, what is returned is a couple things. It is the winner, the move history, and the reason for winning, I guess. So when you get the move history back, you can throw it into this game as text, and then you can just walk through the game in case you ran it and you don't want to look through the terminal output of everything, hopefully. Or if you want to save some move histories. There's a lot of different uses for it, but this is just for debugging for your benefit. Cool, so that's isolation. Again, if you have any questions over this, you can throw it in the chat, and then I'll answer at the end of this, or you can post a note on Piazza if you're watching this recorded. There's a lot of ways to reach us. So now I guess we're going to go over the notebook, which hopefully should be pretty straightforward. Do you want to go over the notebook or do I can't.
It's fine.
Cool. So Trailblazer isolation, the variant of isolation changes every semester. Last semester it was swap isolation. This semester it's Trailblazer isolation. And the certain variant of this, so in typical isolation, hopefully you guys have watched the lectures and know about it. When you move your queen, the space that it previously occupied is now blocked, and it moves to the new space. So in this particular variant, when they move, the same rules apply, such that the space that it previously occupied is blocked, but also a trail. So let's say, Q1, Q2, this is a board state, and it's Q1's move. And Q1 wants to move from here to here. Bam, this is blocked forever as in typical isolation, but also all of the intermediary spaces are temporarily blocked for the next turn. So Q2, as you see, can't move past these orange blocks, which represent the temporary trail. So Q2 is in this situation, it's their turn. Let's say they move from here to here. Right after Q2 makes that move, the trail left by Q1 disappears, and a new trail created by Q2 appears. So it's pretty intuitive, I think. And then let's say after this scenario, Q1 moves somewhere, then Q2's trail will disappear, et cetera, et cetera. There's basically always a trail on the board. That's this semester's variant. So the first things we have are some bookkeeping, so making sure you have all the dependencies and everything's imported okay. This is a cool interactive tool that we use to actually take these pictures. So I need to import all this. In case you want to just get a feel for isolation and make sure that you understand the rules correctly, you can use this. I'm playing against a random player right now, so it might be hard to see the trails because all the intermediary spaces will be... Actually, let me just fix this.
You can play it against yourself.
Yeah, I can throw it on here. So this will make it easier to see. So Q1 makes a move, Q2 makes a move, Q1, bam. Temporary trail, you can't move past it. But once Q2 makes a move, bam, now this trail's gone, but this trail's here. Hopefully that makes sense to everyone. You can play isolation here, you can, the assignment, a lot of this is stuff that we've already gone through verbally. So the important files we have to take care of is notebook, which is this notebook, submission.py, which you can generate from this notebook and is the actual file that you will be submitting to Gradescope. Player submission test contains some basic local tests to check some things on your machine, and test players contains random player, which is the first opponent that you will be playing against on Gradescope, so you can do it locally and you hopefully will know the result of your submission before you submit to Gradescope. And human player, which allows you to play, of course. So the big things that this notebook walks you through is implementing OpenMove eval function, implementing minimax, and implementing alpha beta. So you can see that this doesn't cover everything, and a lot of the end of the assignment you sort of have to develop on your own without the guidance of this notebook. But that is fine. You guys can do it. Evaluation functions, OpenMove eval function. This is mandatory to implement. It is the first 5 points in the assignment. But you can also implement custom eval functions. So instead of doing my moves minus opponent moves, what if I do something like 2 times my moves minus opponent moves? That's a variant of the basic OpenMove eval function, and maybe that's better. A lot of the things that happen with this assignment is that we have never done Trailblazer isolation before, and so the custom evaluation functions that have worked in the past might not necessarily work with this iteration of the variation. So it's probably going to require some clever thinking and experimentation, a lot of experimentation, and it's not something that has a right answer. But this is something that you probably should only be working on later in the assignment. Custom player. Custom player is your player and is what we instantiate on the grade server. Let's see. Some questions. This normally is a big question that people ask a lot. Am I allowed to modify the function signatures? Yes. There are guidelines outlined in the Assignment 1 FAQ post in Piazza. So you can add helper functions if you want. You can change the function signature if you add your new desired function parameter at the very end with a default value. Outside of that, you can do whatever you want. You're free to change the contents of the provided methods in particular. I'm gonna skip ahead a little bit, but I'm gonna go back. In custom player, we have this move function, and by default, when you do a move search, you base your move based on a minimax search. But once you implement alpha beta, then you realize that alpha beta is faster than minimax. So you probably want your agent to move according to the result of an alpha beta search. So go ahead and just change this function to alpha beta, or if you have any other things that you want to modify, you can throw it in move. Let me go back up to where I was. Let's see.
Yeah.
Some of the, this notebook will walk you through how to get the points really, and I can just describe them verbally here. So this one condition, pretty easy, implement OpenMove eval. This next 30 points to feed a random player. What you will need to achieve these points is implement minimax and have your agent move according to a minimax search of depth 2, I believe, greater or equal to 2. And then, moving up, you're going to have to beat the same agent that you implemented to beat 1A. So to implement this, to beat this, you should implement alpha beta and have your agent move according to an alpha beta search of depth greater or equal to 4, which is what it says right here. The one thing that you may note is that when you beat a certain agent, you locally have that agent that we're going to test for the next part. So say I beat a random player 90% of the time, and then I'm having trouble, I get annoyed because I submit to Gradescope all the time and I run out of submissions. What you should be doing is realizing I already have a minimax agent that I can search to level 2. I can just play that locally and use that to test until I, beat it 70% of the time, and then I can submit to Gradescope when I'm sure I get the points. And similarly for this part, ideally you shouldn't have to submit to Gradescope too often because the random player is provided for you, and you can just build on what you locally have further up. Yeah, cool. I will hit those up in a second. I see your questions. Yeah. as for submitting to Gradescope, we have these submission requirements because typically the Gradescope servers can't handle everyone submitting all the time. It gets clogged up and really slow, and then it takes forever to get people's grades back. So we limit you by submission because of that practical reason, and also as a pedagogical reason. We don't want people to just be brute forcing it, so submitting every time and hoping, trying something random every time without thinking it, not really testing, and then just sort of trying to brute force it. So the pedagogy is that you should maybe use 2 hours to think about the changes that you should make to get a better result. But there also is a very practical reason behind it. So we changed this to 3 submissions per 6 hours. We used to have it 1 submission every 2 hours, but then there is a very good argument for people, say, who go off to work, and I have 30 minutes to work on this assignment, and then I go off to work for 8 hours. I'm losing a lot of potential submissions. So you can submit 3 times in a cluster, wait 6 hours, and then submit the rest later. This is, I think, a good change. This is the exporting the notebook script. So this is the script that you run to actually turn the notebook into submission.py to submit to Gradescope. Cool. OpenMove eval. This is pretty covered in the lectures. The test for correct OpenMove eval is just tests. It spits out the result of your evaluation function on a test board. I think the correct number is -9, but you definitely should set up in the local test file, play with different boards and see if your evaluation score matches up with your manual calculation of it, if you're worried about this. Yeah, as you can say, you can edit player submission tests, and you are absolutely encouraged to do so. I mentioned this before, you're going to have to adjust move as you make better search algorithms. And then you can adjust the function signatures with, at the end, default parameter values. Cool. Custom player. This is what we instantiate. So in search depth, this is a function or a parameter that we provide, but some people decide to use it, some people don't. Typically, what this is used for is when I said, for example, a bot uses alpha beta to a search depth of 4. Whenever they move, they will simply call an alpha beta search with a certain depth, which is 4. So it'll search to 4, and then it will make the move that it returned. But sometimes, depending on how efficiently, maybe if you've implemented node ordering, then you have a lot more time and you can go to search depth of 4. Or maybe you have some inefficiencies in your code and you always time out at a search depth of 3. So maybe you should set that to 2. So this search depth actually is the depth that your agent, in the context of isolation, uses the minimax function with. You don't actually have to set it here. This is just something that we provide for you if you want to do, easy experimentation maybe with different search depths. Utility. This is a little bit distinct from OpenMove eval. So say there are some cases where I don't want to use the value returned by OpenMove eval. Say I have an insight into isolation, and I know when a certain board state occurs that the heuristic of OpenMove eval no longer is as accurate as I would like it to be. And maybe I should use this other heuristic that I developed for this certain board state. This is what utility is recommended for. You have a lot of freedom with how you use the functions and parameters in this assignment, but these are just what we recommend. So this is the difference between utility and evaluation function. Minimax, again, I said this before verbally, but with this implemented, you should be able to get all your points in 1A. It's just the general, implement minimax. Depth, is used. I saw some questions with this on Piazza. There are some different ways that you can use this parameter. The local tests assume that you are using depth to recursively call minimax in decrement depth every time you recursively call it. But if you iteratively increment depth or some other usage of depth, then the local tests are going to be, you're going to have to adjust them a little bit for your particular implementation. These two tests, so beat random is essentially what is called on Gradescope. So this should give you a good idea of what your results will be. We provide these checkpoints. Yeah, so hey, you should be getting all the points on 1A, and then later down you should be getting all the points on 1B. Alpha, beta, same thing. This is where you should implement the algorithm. Lack of local tests. So once you get later on in the assignment, you're going to realize that there aren't local tests provided for things, and we encourage you to create your own local tests in whatever way you want. Developing tests for experimentation with this assignment is a really big part of it. So putting it out there, you're going to have to adjust these tests. Add on to or adjust these tests as the assignment goes on. So just be, prepared to do that. This is talking about some of the additional points beyond alpha beta, some tips. Custom evaluation function. So I'm going to put this out there in general. I think coming up with a custom evaluation function is pretty hard. You might not find a better evaluation function than my moves minus opponent moves. It's pretty difficult. You may think that you have a certain idea, but then when you actually put it into practice, it won't make much of a difference. Maybe like 2 games out of 100 or something. That's just been my experience. Maybe one of you has a particularly good insight and can develop a great one. But in my experience, evaluation functions have less of an impact than actually optimizing your code and optimizing the search. So searching deeper is a little bit better than searching with a better heuristic, I guess. I would focus on depth rather than a heuristic, or both. That's the best way to go. Cool section. So a little bit about the extra credit. There is extra credit in this assignment and most of the assignments here. The credit particular to this assignment is a competition-based one. So when you complete the assignment, we're going to collect all of your bots and we're going to play them against each other, and we'll go over how that's done. But the top 10 people get bonus points. Top 10 people in the class. I think we're going to separate P and NP sections. We'll make a post about that. But these are the point breakdowns. So if you win, you get 12 bonus points added to your assignment score. Second best 10, third best 7, the rest get 5.
You might even increase the number of people who are getting the bonus points.
Yeah, this is subject to change. Since it's extra credit, we might be changing the points and like the number of people who get points. But there is extra credit. Some assignments do not have competition-based extra credit and don't have a limit on how many people can get it. So if you're worried like, only 10 people get extra credit for this assignment, yes, I would consider that particular this assignment and not necessarily for ones in the future. Again, if you have any if you have any suggestions on how to improve this assignment, if you see a typo or a bug, there's already been a lot of helpful feedback on Piazza about certain things that need to be fixed with the assignment, or maybe points of improvement, and we really appreciate that, guys. We are always looking to make this thing better, and it's changing every semester, so it's a little bit hard to have it perfect every time. But if you have such a suggestion, please let us know on Piazza, and we will look into it. So that's the notebook in general. Some notes about local tests. I guess I went over this stuff, but in particular, our provided tests are not enough to get an A on this assignment. You are definitely going to have to write your own. Gradescope testing. So this is maybe a little bit more interesting and relevant part of this stream. This is a point breakdown. There's 3 different assignments on Gradescope. This is due to resource allocation and also helping you guys, once you have conquered one section, you don't have to worry about resubmitting, maybe losing in the past. So we have it separated up. In terms of grading the assignment, when you submit all of your, submit submission.py, say you submitted 3 times as, this little picture shows. You're going to have 3 scores, and we will record the score that is marked as active. So when you bring up the submission history, you can see this little activate button. You should push it on the score that is the highest. That is a score that we will actually be transferring over and recording. So be sure to do this. Some people get a score of like 25 or 20 on the last section, try something new, and then get a score of 0. And then they're like, oh, 20 points is good enough, I'll just stop. And then they forget to remark the past one as active. So be sure to do that. That can cause some issues. What's going on under the hood of Gradescope, so it's not this big black box. Each submission that you put up will play 20 games against the listed opponent bot. That is going to be 10 games as Q1, 10 games as Q2, so that no one has that Q1, Q2 advantage. If we played 20 games without any changes to things, then it would just play out the same 20 games every time. So you'd either get a win rate of 1 or 0. And so to avoid the same game being played out again and again, the first 2 moves of each games are randomized. So in this way, every game that is played is a new one, and we're not playing out the same game every time. So be sure to incorporate this locally. I saw one Piazza post already that was, when I play 100 games on my local machine, I get a win rate of 1 or 0. Because you should be mixing things up to truly evaluate the performance of your agent and not necessarily the result of one, deterministic game. You should incorporate this change locally. So that's in general what's happening under the hood. There's not things that are super optimized that we're keeping from you. So when we say you're playing an agent that is using alpha beta to depth 2, there's no other optimizations besides that. It's not doing node ordering or anything. Besides for the very last bot, which is secret evaluation function, there is no hidden optimizations going on. So some final thoughts. Keep up with Piazza. People post a lot of useful insights. So if you're stuck on a certain problem, there's an FAQ that has a lot of useful information. And maybe if you search in the search bar, you can find someone who ran the same issue and maybe got a teacher or student response that will help you out a lot. Code reviews. There are code reviews. If you want a TA or instructor to review your code, we strongly suggest that you go to office hours, which were recently posted. There's a Piazza post with all of everyone's hours. So you can just jump into Google Hangout with them and talk about it. We also have a template for a code review. So if you look on Piazza, you can find this template. You should fill it out with your certain details posted as a private note on Piazza, and an instructor will hopefully get to it. Piazza can get pretty crowded sometimes. We might not get to it instantly, but we'll take a look. You're definitely going to hit a block or a wall in terms of code, and hopefully you get that sooner rather than later, because in the last couple days of the assignment, there's a lot of students who would like instructors to look over their code, and we don't necessarily have enough time to devote all the attention that we would like to each individual person. Other than that, start early. Again, it's going to take you a while to complete this assignment, and we don't want you guys rushing at the last minute.
There are a few questions that people have.
Sure. So I'm just going to go down it, I guess. How is it recommended for us to play against each other? So if you're talking about student to student, there isn't there isn't really support for that outside of the bot fight. And if you send someone your custom player code, then that's just plagiarism at that point. So don't do that. I guess if you're interested in playing against your students or your fellow students, you can. That is something we've talked about with including support for, but it hasn't been done yet. Maybe in future semesters we would like to incorporate that.
What they can do is actually play their alpha beta against Minimax.
Yeah. So what before I briefly mentioned, you should know what you're going to get on Gradescope before you submit. That's because throughout the assignment, you have the bot that you're supposed to beat for a certain win percentage. So you can set up local games that's just, isolation, player 1, player 2, and then play isolation. Maybe incorporate some elements of randomness like we talked about. But just doing local games is definitely encouraged. Can I change the search depth of the custom player? Yes, absolutely. You should change search depth to whatever you find such that you don't time out, but you still get the deepest depth that you can get. That is something you should experimentally determine. I think in general it's around 2, 3, or 4, but find out what it is for your code. Can I modify the constructor for the custom player? When I use get my moves and get opponent moves, I'm getting an invalid move. Any idea what I could be missing? I pass player and minimax for both functions. What this could mean is that you are getting the moves for the wrong player and you're trying to execute them. So if it's my turn and I accidentally use get inactive moves, that will give me a list of moves that if I try to make them will result in an illegal move. I would double check your code for that. That's probably the case. Can I modify the constructor for the custom player and introduce a new default property? Yes, you can. Again, just give it default value for sure, because when we instantiate your agent, we're just going to be passing no arguments to it. And so if it's expecting an argument, it doesn't get one, it's going to crash on Gradescope and you're going to get 0 points. So just be sure to follow those guidelines. Is the board on Gradescope really 7x7? Yes. The Gradescope board is the same as the board that we provide you in local tests. The environment should be the same. Is there extra credit for all students facing each other? Is the ranking? Yeah, I think so for now, I think we're considering P and NP as independently. We will post an update soon about that. There is some time before that, before the bot fights do. So my first 2 moves are randomized 2. Does the first 2 random moves mean that the random move? I keep missing the highlight ones. Given that search depth is perhaps the most important factor in results, is it likely to be beneficial to kind of do a different data structure like NumPy matrices? So in the past, students have found room to optimize with vectorization where they found it. I don't think that in particular the Minimax algorithm takes advantage of some of the optimized NumPy data structures off the top of my head. But probably marginally, but I don't think substantially like some, matrix, there's no matrix multiplication going on. But if you find a place to optimize using NumPy, feel free to do so. I think the main things where NumPy has been an advantage is where you're trying to implement a custom strategy. So say, for example, I want to, count the number of blocks in a certain row of the board state. That can be achieved faster in an NumPy array than in a, 2D list of Python. But for default Minimax or Alpha Beta, I don't think that there is a huge benefit, but I would love to be proved wrong. So my first 2 moves are randomized 2. Does 2 random moves mean that 1 random move for my opponent and 1 on my behalf? Yes. So when the first 2 moves, player 1 puts their queen down anywhere on the board, and player 2 puts their queen down anywhere on the board else, those moves are randomized in Gradescope, the first 2 moves, just so that we avoid such that every game is different and the evaluation of your bot is a little bit more accurate and we're not playing out the same games every time. That's what we mean. It was recommended to read me, or I saw it there anyway. It is possible we don't time out locally between different machines we type out, sometimes on Gradescope. So, historically, that hasn't been a ton of an issue. So, I guess if you're cutting it very close on your local machine, maybe the CPU on Gradescope is slower and searches to a shorter depth. I don't think that's really been a huge problem, but one thing that...
Unless they have a really...
Oh, yeah, I guess that
they
depends.
have a supercomputer sort of a machine.
Yeah, maybe your computer is much faster than the resources on Gradescope. That's actually a good point.
That shouldn't be a big problem. Like, that would hardly make much of a difference, I feel.
So, one thing that you should be implementing to maybe help you out is handling timeouts. So, say I'm searching to a depth of 6 on move 1. That's probably impossible. So I search, so far down the tree, and then I realize that using the time left function, I have like 100 milliseconds left. One thing that probably would be beneficial is to just say, stop the search completely and just return what I have best so far. So a word of warning against this is that, I think this is in the FAQ too, but using the results of an incomplete search is very discouraged, and you're not going to get very good results. So this is mainly saying iterative deepening. Say I complete a search of depth 5, and then I begin my search of depth 6, and then I'm like, oh no, I only have 100 milliseconds left. I better stop and return the best result. The best result is not the half search of 6, but rather the full search of 5. And I mean, that's probably a little bit more than was asked in this question, but if you're worried about that situation happening, incorporate some timeout element like that. What is the time limit used by Gradescope for custom versus random player? I believe it's 1 second. I think that is stated in the notebook. But
and it is same for even local tests.
Cool.
Yeah, for every game that we are playing, it's 1 second.
Neat. So 1 second. Does the first random moves in practice means the opening books are not very useful? Opening books are useful from the third move onward, but because there's going to be a lot of different permutations, it would behoove you to take into account reflection and rotation more, as said in the lectures at some point, I think. So opening books are useful from the third move onward. It's a little bit, maybe a little bit more tedious to implement, but I think that's still useful for you. It's still a good way to approach. Cool. Those are all the questions for now. Can we parallelize the code? Yes. I think there's actually, I'll look into this, some code that a student shared for parallelizing games. So yes, if you have to play 10 games, maybe doing one game, then another game, then another game is shorter than using 8 of your cores, and then you only really have to wait for the outcome of one game. And that's a great question. And you should parallelize the code in local tests, but in terms of
in terms of the algorithm, I don't think you should parallelize the code.
Yeah.
The parallelization of code will only help when you're running a lot of games on your machine for testing.
Mm-hmm. So, and also when you're submitting to Gradescope, do not use multi-threading. There's some issues with that, and you probably won't be needing it anyway. But local tests for sure use multi-threading. In other contexts, probably not. Will the bot fight also incorporate 2 random moves? That's a great question. I think the last bot fight incorporated 1 random move. or a combination of random moves and not random moves, such that if you had an opening book, for the first 2 moves you could use it, but there definitely still was randomness at some point.
Yeah, we will have to add some randomness.
Mm-hmm. We'll release a post about maybe the specifics of the bot fight. Can you parallelize for a single search on Gradescope? No. Yeah, no. Some people sometimes post on YouTube Live questions. Will repo updates be announced on Piazza every time there's an update? Sorry, this is answered elsewhere. Yes, I think in the announcement of gameplay, there's a little, this probably should be publicized more, but there's a little note here. It says, if you haven't pulled the most recent, this is the time of the most recent update. If there is a critical update, so say, for example, we found a huge bug in the isolation framework that breaks the whole thing. That is unlikely, but if that happens, we will make a post and we'll tell everyone to pull again. We don't expect this to happen. Normally, a lot of the issues are ironed out in the first day or 2 of the assignment release, and then from then on, it's smooth sailing. But yes, if there's a small update, like sometimes we fix a typo or something, that probably won't be announced because it's not that big of an issue. Yeah. Is there any questions on your?
No questions.
Is there any more in the YouTube
No.
chat?
No.
Cool. So we're going to call it here. It's been about an hour, so maybe that was a bit longer than expected.
Yeah, but feel free to post anything you want to on Piazza. If it is something that is really critical towards your code or something that is a really particular problem that you are facing, you can always do a private post. Otherwise, feel free to post anything on Piazza. We are there almost all the time, so we'll get back to you as quickly as possible.
Yep. Cool. Remember, start early, guys. If you're watching right now, that's a good sign. You're already on the right track.
Right. Absolutely.
And I guess let me bring this up. We will post this link. The recorded, it'll take some time to render, but we will post it in the Piazza thread for the YouTube Live. But in the meantime, I hope you guys enjoy the assignment and enjoy the rest of your week wherever you may be.
All right. Bye.